Hello everyone, I'm going to go over how to derive the unit circle starting from scratch. So let's pretend I'm giving this unit circle right here. So I'm going to start. So we have a 30, 45, 90, right? So 30, 45, 60, 90. We have this is 180, this is 270, and that's 360. So the full circle will be 360. But let me start by actually doing that. So I'm going to label the degrees right here. This will be 0 degrees. This will be 90 degrees. This will be 180 degrees. And this here at the bottom will be 270. That's 180 plus 90. And of course, the full rotation will be 360 degrees. Okay. For the 30 degrees, I'm going to use a special right triangle 30, 30, 60, 90. For the 45, I'm going to use a special right triangle 45, 45, 90. And then for the 60, I'm going to use the special right triangle 60, 30, 90. So let me go ahead and fill in the blanks right here. So for the 30, opposite to 30 here, so I know that this one has to be 60, correct? Has to be 90 right here. So the sum of the interior angles inside the triangle has to add up to 180 degrees. Um, Here, by definition, this is going to be 1. That's going to be square root of 3. And the size opposite to the 90 degrees is always 2 times the size opposite to the 30 degrees. So this has to be 2. For the 45, size opposite to congruent angles are congruent. If this is 45, that has to be 45. Why? Because 45 plus 45 is 90, and 90 plus 90 will be 180. Um, this here, by definition, is going to be 1, length of 1, and this has to be square root of 2. If we do Pythagorean theorem, we will get that, square root of 2. For this one, if this is 60 and that's 90, that has to be 30. Why? Because 30 plus 60 plus 90 adds up to 180. By definition, we said that the size opposite to 30 is going to be 1. The size opposite to 60 is going to be square root of 3. And the size opposite to 90 is always 2 times this, the size opposite to the 30-degree angle, so 2 times 1 will be 2. All right, now that we have derived this one, we're going to use the unit circle with the coordinates or an ordered pair of cosine theta and sine theta, meaning the value that we find here is going to be attributed to cosine. The value that we find here is going to be attributed to sine, meaning this is your x component and this is going to be your y component. This is a unit circle, meaning that the radius all around the circle has to be 1. I'm going to demonstrate using this one of them. So like here for 30 degrees, if we're finding let's find the sine. So the sine is going to be, well, let's write the SOHCAHTOA here to make sure that we are getting correctly. So TOA, right, for SOHCAHTOA here, so sine will be opposite over hypotenuse. In this case will be 1 over 2. We did mention that these are going to be the x components and the y components. So this will be cosine and this will be sine, right? So it is the sine of 30 will be opposite over hypotenuse, which in this case is going to be 1 over 2. So let's label this 1 over 2. Okay. For this one here, for the cosine of 30, okay, for the cosine of 30, I'm going to have, for the cosine of 30, I'm going to have adjacent over hypotenuse. So in this case, it will be, the adjacent will be right here, right? Adjacent, opposite, and hypotenuse. So the adjacent is going to be radical 3 over 2. And I'll show you like another trick on how to come up with this here. But this is the general idea, right? So based on this one here, if this is my x component and this is my y component, so like I'm just going to do this quickly here. If the x component is square root of 3 over 2 and the y component is 1/2, I say that by definition that has to be 1 because the radius is 1, right? So it's a unit circle. So all this radii will be the length of 1. So how can I prove this one? Well, I know here that x squared plus y squared equals to 1, right? The radius is 1. This is the formula to find the uh, um, equation of the circle. The radius is 1 here. So the way you're going to do this one, if you have x component, you can just do square root of 3 over 2 square plus y, and in this case y is actually 1 half over 2 square equals to 1 square. This has to be true if this is a right triangle. You can also think of Pythagorean theorem, right? So this will be actually, well, the square root of 3 square will be 3, 2 square will be 4, so this is going to be 3 over 4, plus, well, 1 square is going to be 1, 2 square will be 4, so this will be 1 over 4. Well, this actually ends up being 3 plus 1 will be 4 over 4. 1 square is 1, 4 over 4 is 1, and 1 equals to 1. Now, you don't have to derive all this. I'm just showing you so you can see the way that this works, right? Why is this true? Why is the next one going to be true? Actually, no, the next one. The next one is the square root of 2 over 2. How'd you get that? I'll show you just now. So I look at the 45, 45, 90, right? They're asking me for cosine and sine. Let's do sine first. So sine will be opposite over hypotenuse. So opposite is 1, hypotenuse is square root of 2. So 1 over square root of 2. But 1 over square root of 2, after I rationalize the denominator, I get square root of 2. Well, square root of 2 times square root of 2 is square root of 4, but square root of 4 is 2. So this will be, always will rationalize to square root of 2 over 2. The same thing for cosine. Cosine is adjacent over hypotenuse. Well, I already rationalized it, so I get the same thing. Now, everything here in quadrant 1 will be positive. Okay, so and that's going to be important later on. The next step here is the reference angle of 60 here. So the angle created here, when I open counterclockwise, that'll be 60 degrees. How do I know the cosine value and the sine value? Well, I can just do cosine here. That's adjacent over hypotenuse. So that will be 1 half. And for the sine of 60, that's going to be opposite over hypotenuse. So notice that that's going to be a square root of 3 over 2, right? So that's only the first quadrant. But that is the most important quadrant because everything else will come in really easy. So watch this, okay? Now, I did mention that all these values are positive here, right? Just kind of like how you know how you have the x comma y, those are positive. This one is going to be, I'll put it right here, like negative x, positive y, right? Here, this is negative x, negative y. So the components are going to be negative, positive, negative, negative, and then here are going to be positive, negative, right? You can kind of think of that. Another way you can kind of think of this is I use an actual trick that you can remember. So like I actually use this trick. It's called all students take calculus. Now this means that all the trig functions, sine, cosine, and tangent, are going to be positive. For this one, only sine as n is reciprocal will be positive, meaning that all these values here will be positive, but any other functions here will be negative. So in this case, cosine is negative. Now, you already created these values here. All you have to do is reflect them, and they're going to be the same thing, with the exception, of course, that the x coordinates or the x component will be negative. So let's just write them down. Okay, and I'm going to show you a pattern, okay? So they have to be the same, right? So this is going to be 1. I'm going to just put fractions, okay? So you guys can see like where I'm getting this pattern. So this is the same. So you're going to do 1, 2, 3, and this one is going to be 1, 2, 3. You take the square root of the numerator, okay? That's going to be just 1. This one, do that, do that, do that, do that. Well, that's just 1. And then you put it all over the divisor. So that's a trick, you guys, that you guys can use. Now, I did mention that sine is positive, meaning the y component will be positive, but anything else will be negative. So that means that all these values here are going to be negative. Okay, and that's it for this part. Now, because we're already here, might as well just continue and do the whole thing, okay? All right, so let's do this one here. You don't have to use different colors. I'm just gonna use different colors. All right, for this one is a little tricky, but it's actually not that bad. So tangent here is positive, meaning that cosine and sine are gonna be negative. So the values here, you know that are gonna be negative, both of them. I know I'm gonna have fractions here. Same thing here, so might as well just get that done right now. All right, for this here, you notice that the angle, it's a initial angle here, and it went all the way. I'm gonna, all right, notice that the angle created started from here and went all the way to 210. The reference angle here created by the 210 will be 180 plus 30. So this angle here, call that the reference angle, that's 30 degrees. So all I need to do, I can kind of look at the 30 here, and I can say, well, I want to find the cosine. Well, cosine is going to be adjacent over hypotenuse. So this is going to be square root of 3 over 2. The sine is going to be opposite over hypotenuse, right? So this is adjacent over hypotenuse, that's opposite over adjacent. Sorry, adjacent over hypotenuse, and this was going to be opposite over hypotenuse. So this is going to be 1/2. And you guys will see the pattern, right? So this will be 1. Well, I know it's all over 2. So that's a 1, that has to be a 2, that has to be a 3. That's a 1, 2, and a 3. And then just take the square root of the numerator, and you should be in good shape. Okay. I did mention that they're all negative, so let's just make them all negative. All right, let's do one more, and then we are done. This is actually going to be, you can just do the same thing as this one. It's going to be 3, 2, 1. And this is going to be 3, 2, 1, all over 2. The same as that one, but you just have to worry about the signs now. Cosine will be positive, meaning these are positive. Everything else will be negative, so all this will be negative. Of course, don't forget to take the square roots. Right? Don't forget to take the square roots. And that's it. Yeah, let me fix this a little bit. And then we should be done after that. So this should be 1/2. All the y components are going to be negatives, right? There's negatives. Everything now should be positive. And that's it. That's the completion of the unit circle. Thank you guys for watching. Hope you guys learned the unit circle. I do want to show you something else though before I finish. The radians. This here will be 0 degree radians. This is pi over 2 radians. This is pi, the famous pi, right? 2 pi will be a full rotation, so this is going to be 2 pi. And then this here will be 3 pi over 2. How did I do it? All I did is 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. 4 pi over 2 is 2. All right, that is it. We'll see you guys in the next video.